Neil deGrasse Tyson once remarked, "The universe is not only bigger than we can imagine under most scales, it is bigger than we can imagine." This profound statement encapsulates humanity's relentless quest to understand the cosmos. We have long wondered whether the universe has an end or a beginning, and whether tools like the James Webb Space Telescope JWST can finally uncover the edge of the observable universe. Throughout history, our pursuit of knowledge has continually expanded our horizons. Where once the edge of the world lay beyond the horizon, today we deploy advanced telescopes to probe the cosmos, seeking evidence to determine whether the universe is a finite space. With the JWST, we may have made a groundbreaking step toward answering this fundamental question. The concept of an edge is itself enigmatic. If the universe has an edge, is it the end of creation, or could it be a threshold to another universe or unknown dimensions? Just as Earth, the solar system, and the galaxy have edges, so too might the cosmos. Yet the universe does not end there. Tyson aptly points out that the problem lies not with the universe, but with the limits of human imagination. The universe is so vast that we can only attempt to search for its beginning and end using tools that are modest in comparison to its scale. Currently, our telescopes allow us to observe up to 46.5 billion light-years in every direction, a span representing a total diameter of about 93 billion light-years. Despite this, no definitive edge has been discovered, and the mass of stars, galaxies, and cosmic phenomena observed within this vast expanse remains unfathomable. It would take us millennia to explore even the portion of the universe we already know. Yet, driven by insatiable curiosity, we persist in our quest to understand whether the universe has an edge and what it might reveal. The JWST is central to this endeavor, identifying objects deep in the darkness of space. Among its discoveries are fully developed galaxies that defy existing theories about the early universe. Humanity, Tyson argues, is often confined by its need for beginnings and endings, thinking in terms of fixed structures and spatial limits. However, grappling with the cosmos stretches the limits of perception, forcing even the most open-minded astronomers and cosmologists to confront their limitations. The sheer scale of the universe, its countless stars, planets, and cosmic phenomena requires an expansive and adaptive mindset. Yet scientists are realizing that their previous theories may have been constrained by assumptions that prevented a true understanding of the universe's nature. The JWST has already revealed 6 galaxies so old and perfectly formed that they challenge the foundations of cosmological models. Designed to peer into the so-called dark ages of the universe, where the first stars and galaxies were believed to form, the telescope instead discovered mature galaxies and clusters that defy expectations. These clusters, consisting of millions of galaxies, suggest that the universe's formation may have unfolded differently than previously thought. Remarkably, these galaxies have redshifts greater than 10, indicating they existed when the universe was merely 2% of its current age, just a few 100,000 years after the Big Bang. Tyson's observation resonates here. The problem is not the universe itself, but humanity's limited understanding. As the JWST continues to uncover unprecedented findings, it challenges our assumptions and reshapes our view of the cosmos, revealing not only galaxies from the so-called dark ages, but also deeper mysteries about the universe's origins and structure. Years after the Big Bang. These discoveries do not show us a dark world, but a universe that actually looked much the same as it does today. These discoveries are so incredible that scientists initially doubted Webb's findings, but the spectroscopy of the telescope has confirmed every single result several times over. Spectroscopy played a crucial role in confirming the distance and properties of the extremely distant galaxies. Astronomers use this method to break down the light of an astronomical object into its different wavelengths and thus determine the age of the light source and physical properties such as the chemical composition. Webb's results showed that these galaxies are not only very old but also contained elements and a number of stars that do not fit with a young universe. The temporal edge of the universe is currently moving further and further away from us. But what about the spatial edge? Have we already found it, or can we find it? Here we come up against a paradox, because if we are looking for something in a space that exists now, we would have to see this space in real time. Imagine you are looking for the walls in a very large concert hall. It's dark except for a few small LED lights at a distance of 10 or 20 meters. You don't know exactly how big the room is, nor can you see the walls. You would have to personally search for the edges by feeling your way around. This option is not possible for us in the cosmos because we cannot travel through it personally at the moment. The other option is that you have a telescope with which you look further and further. You focus on the bright places, or in other words, where the LEDs are, because you can see at least a little bit there. If your telescope is good enough, you might be able to spot the walls of the room at some point. But the tricky thing about the universe is that it's moving at the exact moment we are looking. With our new super telescope, the JWST, it's as if the walls of space are expanding while you are looking, so you have to make sure that you keep up with the movement of the walls as you develop your telescope technology and range in space. We encounter another phenomenon that makes the search for the walls or an edge more difficult. Light takes time to travel through space. With the JWST, we see light that has traveled 4 light years, 100, 1000, or even 13 billion light years, so we only ever see the past. Strictly speaking, you also see the past in your room, but the light from LED 60 or 100 meters away only needs a fraction of a second to reach your eyes, so here we can say that you experience space in real time. But in the universe, the temporal dimensions are different. We can already see the nearest star, Alpha Centauri, as it was 4 years ago. Of course, we can say that the universe must have been even smaller 400,000 or 5 million years ago, because it hasn't expanded that far yet. Nevertheless, we have not yet succeeded in finding any signs of a spatial limit. Instead, we have found evidence that the universe is not expanding at the same rate everywhere. This could mean that our cosmos does not have a uniform, homogeneous form, but is structured in a way that we have not yet recognized. The JWST's departure into infinity raises profound questions. Have you ever thought that it might be a mistake to look for boundaries or a beginning? Perhaps this new era of space exploration wants to show us that we have to stop thinking in terms of limited dimensions in order to go beyond what we have considered to be true so far. In its own way, the JWST shows us again and again that there seem to be no limits, even within the universe. Again, the telescope found structures that break boundaries, and it wasn't even about searching for an edge. James Webb took a look at a distant galaxy and found such a huge active galactic center that scientists were speechless. At the center of this young galaxy, only about 570 million years after the Big Bang, a quasar with a black hole 10 times the mass of our Sun was already raging. Black holes that are part of an active galactic nucleus emit an unusually large amount of light, which is produced by the friction of the material flowing into the black hole in a spiral. Such galactic centers shine trillions of times brighter than the brightest stars. Even in its search for exoplanets, the JWST is constantly showing us that we must stop thinking in terms of limits. We must strive for diversity and infinity if we really want to understand the universe. HIP 65426b was already identified by Hubble in 2017. But now, thanks to Webb's unique new capabilities and highly sensitive spectrometers, we have even clearer data from this distant world. HIP 65426b is a huge gas giant about 12 times larger than Jupiter. It's located at a distance from its star that is 100 times greater than the distance from the Earth to the Sun. That's more than twice as far as the dwarf planet Pluto is from the Sun. Using Webb's coronagraphs, cameras, and various filters, this planet has been imaged directly for the first time, which is an absolute exception, as most exoplanets are discovered by transiting in front of their home star or by indirect methods. These are just two extremes and two more examples of the fact that we have to reckon with so many phenomena, peculiarities, exceptions, and ever-new dimensions to discover in the universe that it would be downright foolish to look for an end, edges, or limits.